How do you deliver industrial cargo of hundreds of tons without rails? Release a tractor with a locomotive engine onto the open highway. This is a pure logistics dead end. The steel tracks simply terminate here. Geography blocks the standard delivery route. Remote industrial sites remain completely isolated. Standard transport instantly fails under extreme physical mass. Engineers had to forge a radical answer. Meet the heavy haul logistics titans. These tractors easily exceed 9 meters, 30 feet of solid reinforced steel. Their diesel engines rival small buildings. Railroad pulling power meets fragile civilian asphalt. The highway physical limits fight back instantly. Asphalt groans, tires deform, torque spikes, metal screams. Yet the mechanical beasts move forward. They actively pull hundreds of tons. No rails, just wheels. These machines exist solely to transport impossible masses across the globe. The first answer to the absence of rails came from the Australian deserts, which demanded that the Kenworth C510 model operate over transcontinental distances. Manufactured in the early 2000s, this machine faces utter geographical isolation and constant environmental pressure. The harsh continental environment forced engineers to abandon standard automotive designs and build a full-fledged freight locomotive that runs on rubber tires. Out in this wasteland, a mechanical breakdown stops entire industrial supply chains for days. No backup exists. A massive road train of 4 heavy trailers moves steadily along a heavily rutted dirt track. Red dust billows violently into the scorching air of the Australian outback, creating a dense particulate cloud visible from miles away. The intense heat haze blurs the massive steel grille as the tractor pushes forward through temperatures exceeding 40 degrees Celsius. At over 50 meters in extreme length, this rolling steel structure perfectly matches the dimensions of a regional railway train. The scale is staggering. The entire rig reaches a maximum total mass of up to 105.6 metric tons when fully loaded. It bypasses complex transfer hubs, hauling massive quantities of raw ore and bulk fuel directly from remote inland mines to coastal shipping ports. Pulling this immense weight across soft ground requires industrial-grade internal architecture. Under the fiberglass hood sits a 19-liter Cummins K19 engine generating 600 horsepower. The massive inline 6-block drives a specially reinforced 18-speed manual transmission equipped with deep reduction gears for sudden inclines. The 6x4 drivetrain distributes power across dual rear differentials, maintaining constant wheel traction on loose gravel and highly uneven terrain. Heavy-duty parabolic springs and massive shock absorbers keep the high center payload completely stable across shifting desert surfaces. The exhaust note is a deep, steady mechanical drone echoing across the empty plains. These machines push the absolute physical limits of heavy highway transport. A standard commercial truck cannot handle the sheer friction and structural mass involved in these continuous operations. One famous C510 unit set an industrial benchmark by towing an astonishing 131 tons of cargo across the arid wasteland. Maintaining that forward momentum requires flawless mechanical integrity under extreme thermal stress and constant vibration. Zero room for error. The structural endurance of these machines completely defies conventional automotive lifespans. One documented tractor covered exactly 1.2 million kilometers of abrasive desert terrain. 1.2 million kilometers on the original cylinder block. While Australia built highly specialized desert rigs, Africa and the Middle East adapted military surplus for civilian turbines, the Oshkosh M911. Born in the late 1970s, this machine bypassed standard commercial development. It hauled heavy battle tanks. Then, civilian contractors saw its real potential. The tractor measures 9.9 meters in length and stands 3.3 meters high, a rolling 2-story fortress. Inside the compressed visual space of the steel cab, operators find no luxury, just rigid levers and the deep mechanical roar of a 14.6-liter Detroit diesel V8 engine. 450 horsepower flows through a heavy-duty 5-speed automatic transmission. The military gear ratios convert engine speed into pure pulling force. But the absolute core advantage lies in the 8x6 wheel formula. 3 driving axles lock the truck to the earth. The heavy grip of 6 powered wheels bites into the scorching asphalt. Total mass with a fully loaded trailer exceeds 74.8 metric tons. This equals the combined weight of roughly 50 passenger cars resting on one moving chassis. Moving that massive weight forward is basic physics. Keeping it stable requires advanced military engineering. Hauling civilian turbines and massive steel structures creates a dangerously high center of gravity. This is where the heavy suspension process takes over. Reinforced parabolic springs flex continuously under the immense downward pressure. They absorb and distribute the shifting weight evenly across the rigid steel frame. When the uneven road dips, the thick hydraulic shock absorbers instantly compress and expand. They swallow the raw kinetic energy before it ever reaches the cargo deck. The trailer stays perfectly level. Zero lateral sway. The load remains secure. This exact mechanical stability unlocked remote, railless distances across the African continent and the Middle East. Massive industrial components could now completely bypass restricted rail yards. In major global infrastructure projects, extreme automobile road transport simply replaced the traditional train route. A dull, steady hum fills the air. Air rushes through massive steel pipes. The 28-liter engine breathes heavily, monotonous, constant, unforgiving. Listen closely. North American experiments with civilian super tractors triggered a breakthrough. Engineers sought a solution for logistics. They created the 10.5-meter Mack M45. It remains the rarest machine of the 1970s. The scale crushes conventional limits. Gross weight hits 90.7 metric tons. This matches a fully loaded space shuttle orbiter. Gravity fights every inch of progress. A Cummins V12 block powers the giant, specifically the VT1710 model. 28 liters of pure displacement. 600 horsepower push the steel frame. Cylinders compress the heavy fuel mixture. Combustion generates extreme mechanical force. The contrast defines this entire machine. Massive engine volume meets crawling speeds. 16 mechanical gears control the output. Deep reduction ratios engage smoothly. Torque multiplies through the heavy drivetrain. The tractor moves under full load. Movement becomes pure jewelry. Slow, precise, calculated. Tires bite into the cold pavement. Dual rear axles carry the immense burden. The heavy-duty suspension absorbs the strain. Solid steel components resist bending. Parabolic springs hold the necessary balance. No sudden jerks, zero deviations. The cargo rests securely on the trailer. It carries giant industrial turbines across highways. Massive electrical transformers follow the same path. Railways cannot reach these remote construction zones. Tracks end miles away from the target. The Mack provides the only viable solution. It replaces the locomotive completely. Today, collectors hunt these extreme relics. Only a few original units survive globally. Time erased most of these heavy haulers. Texas hosts one fully operational chassis. Mechanics maintain it in perfect physical condition. It serves strictly for technical demonstrations. New drivers learn the physics of mass. Civilian manufacturing reached its limit right here. The prototype laboratory delivered a masterpiece. Yet, infrastructure demands continued to grow exponentially. After the creation of custom civilian tractors like the Mack M45, the task of moving colossal masses permanently shifted to military engineers. Minus 20 degrees Celsius, 1,400 kilometers across ice-covered highways with an 82-ton turbine. The geography of Central Asia and Eastern Europe demands extreme solutions. Kazakhstan alone spans 2.7 million square kilometers. Vast stretches of this territory completely lack railways. Standard civilian trucks fail here. The solution came from a completely different domain. Engineers at the Minsk automobile plant developed the MAZ-537 in the 1960s. They originally designed it to carry intercontinental ballistic missiles and main battle tanks. The military demanded a chassis that could simply ignore the terrain. Civilian industry needed exactly the same capability. The artillery base transformed into an industrial workhorse. Firing up this machine in deep winter requires raw mechanical force. The heavy starter engages. Metal gears grind against cold, thickened oil. Then, a violent detonation of diesel fuel shakes the 30-foot steel frame. The power plant is a 38.9-liter V12 engine. 38.9 liters. It displaces more volume than 20 modern automobile engines combined. This massive block outputs 525 horsepower. The transmission is a heavily reinforced 4-speed manual with a secondary gearbox. It yields 8 distinct forward gears. The mechanics guarantee pure utilitarian survival. An 8x8 all-wheel drive system pushes through deep snow. Independent torsion bar suspension absorbs violent impacts. A central armored-style cab sits high above massive tires. It gives the operator a commanding view over the frozen horizon. There are no sleek lines. There is only raw pulling power. The contrast is absolute. A military platform engineered for a nuclear standoff now solves civilian logistics crises. It routinely hauls transformers, drilling rigs, and industrial modules into regions totally cut off from the rail network. During one historic winter operation, crews pushed the vintage chassis to its absolute limit. They coupled the tractor to a multi-axle heavy haul trailer. The payload was the massive 82-ton power turbine. Ice coated the steel linkages. The V12 engine ran continuously, forcing power to all 8 wheels to maintain traction on the slick, unpaved surface. The ambient temperature locked at minus 20 degrees Celsius. Through blizzards and cracked roads, the Cold War relic maintained a steady, unstoppable pace. The total distance of this single run reached exactly 1,400 kilometers. If in the East the problem was 1,000-kilometer distances, then in Western Europe of the 1970s, logistics hit the limits of port dimensions. The North Sea oil boom had just begun, demanding immense infrastructure. Massive components had to move from inland factories to coastal facilities. The roads were narrow, winding through dense European landscapes. Standard transport failed. How to deliver sections of oil rigs to the sea without trains? With an air-cooled base. A distinct metallic roar echoes across the valleys long before the transport appears. This is the sound of a West German heavy-hauling chassis manipulating colossal structures through restricted coastal routes. The noise comes from a Deutz V12 engine operating under maximum strain. Displacement reaches 21.3 liters. Instead of traditional liquid radiators, this power plant relies entirely on air cooling, maintaining sustained high revolutions per minute without overheating. The acoustic profile is a heavy mechanical hum of spinning fans and combusting diesel, amplifying sharply as the machine encounters steep inclines. The prime mover itself tips the scales at 20 tons. Its true capability lies in what it pulls. An 8-speed manual transmission channels torque through a 6x6 drivetrain, gripping the asphalt to tow loads exceeding 100 tons. That is roughly the weight of a commercial narrow-body jet moving through residential European highways. Heavy-duty leaf springs and hydraulic dampers distribute this immense pressure, keeping the flatbed stable during tight cornering. Flanked by full escorts, these platforms crawled toward the coastlines. The delivered prefabricated modules were immediately assembled into offshore structures, ready to extract millions of barrels of crude oil from the ocean floor. From North Sea oil platforms to Canadian hydroelectric stations, in 1983, one Pacific P12 completely replaced a freight train. It was a radical shift. This single machine bypassed trains and barges. One truck did the job. The physical footprint is massive, 33 feet in total length. The track measures over 10 feet in width, 13 feet straight up. The chassis alone weighs 37,500 pounds. A standard highway limit is 40 tons. Fully loaded, it hits 120 tons gross weight. That is 3 times the legal maximum. The engine core is solid iron, a 28-liter Cummins V12 engine block, 550 horsepower output. Torque reaches 1,770 pound-feet. A 16-speed manual transmission channels that sheer force. Ultra-low gear ratios multiply the torque output. Gears lock, tires grip. The resulting pull is immense. 6-wheel drive dictates the path. Locking differentials bite into loose gravel. Thick, heavy-duty steel axles bear the burden. The rig enters a sharp mountain curve. Massive stacked steel leaf springs compress hard. The massive load shifts forcefully outward. The springs distribute the crushing weight evenly. The rigid frame stays perfectly flat. Zero flex. Total mechanical control. The sensory impact hits your chest. A heavy mechanical growl builds. The sound bounces off rock canyon walls. A low bass echo rumbles through the cold mountains. This machine dominates dominated remote logging trails. It conquered open-pit mining zones. Then it took over the wide public asphalt. Operators refitted it for highway use. It hauled single isolated superloads. 1983 brought the ultimate hauling test. A 95-ton hydroelectric turbine required urgent transport. No water routes, no rail lines. The Cummins V12 roared. The turbine rolled steadily forward, crossing the borders of two sprawling Canadian provinces over 1,120 kilometers without ever requiring a single river barge. While the Canadian P12 set local records in the 80s, the global standard of the 90s was defined by a tractor originally designed for 60-ton Abrams tanks. The Oshkosh Heavy Equipment Transporter emerged as the ultimate heavy hauler. The M1 Abrams main battle tank weighs roughly 60 tons. Moving that concentrated mass across active war zones left zero margin for structural failure. Engineers built a rolling fortress out of reinforced steel and massive drive axles. Power originates from a Detroit diesel 8V92A. This 14.6-liter V8 engine operates on a two-stroke cycle, firing on every downward piston stroke to generate massive low-end force. The real mechanics unfold on a long, steep incline. The 7-speed Allison automatic transmission takes the immense load. It locks the torque converter to prevent any mechanical slip. The gearbox holds the lower gear, pushing a continuous, unbroken wave of kinetic energy to the drivetrains. There is no high-pitched turbo whine. The engine emits a low mechanical growl. The acoustic frequency hits the human body directly. The deep vibration resonates in the chest long before the sound ever registers in the ears. The gross train weight peaks at 108 tons. Keeping this colossal mass moving forward on unpaved dirt is a matter of applied physics. The truck utilizes an 8x8 wheel formula, distributing torque equally to all four heavy axles. The crucial element is the independent hydraulic suspension. When the heavy chassis encounters a deep rut, the system reacts instantly. The hydraulic cylinder pushes the dropping wheel downward. It forces the tire to maintain constant physical contact with the ground. The massive weight transfers seamlessly across the remaining suspension arms. The heavy rubber bites into the loose gravel. The 100-ton cargo remains perfectly level. Decommissioned military units eventually flooded the civilian market. Global logistics firms bought up the surplus machines to close critical gaps in civilian infrastructure. In remote regions of Africa, these trucks literally replace freight trains. They haul steel bridge spans, hydroelectric turbines, and massive marine engines across territories completely devoid of rail networks. The machine adapts to any environment. A Romanian mining company entirely rebuilt their unit for long-distance civilian routes. The former battlefield tractor now runs exclusively on smooth asphalt, equipped with specialized highway tires, a modernized high-visibility cab, and full climate control. In the 70s, engineers abandoned railway platforms for highways. The goal required transporting 150 metric tons. They needed a completely new machine. The Mack M100SX answered the call, an experimental road giant. Engineers built it exclusively in the 1970s. Its sheer numbers defied standard engineering logic. Gross weight hit 150 metric tons. That equals 3 fully loaded semi-trucks on one chassis. Cab height reached exactly 4.2 meters. Drivers sat at second-story window levels. The steel frame stretched almost 11 meters long, 3 meters wide, pure steel bulk. Every route required specialized transport permits. Police escorts cleared the asphalt roads ahead. A massive 24-liter V12 diesel sat beneath the hood. It generated exactly 625 horsepower. Starting the ignition shook the concrete below. The exhaust sound resembled a marine diesel, a deep rhythmic mechanical throb. Not a standard highway truck, a land-bound cargo ship on wheels. Torque output exceeded 3,000 Newton meters. Raw power demanded absolute physical control. The heavy transmission controlled the raw output. A 20-speed manual gearbox managed the load. It featured specialized dual range gear reduction. Designers built it for impossible transport angles. Critical inclines tested every single steel component. The road gradient steepens sharply. Gravity pulls the colossal mass backward. The driver shifts the 20-speed transmission. Thick metal gears lock into solid place. Massive torque hits the 6x6 drivetrain. Reinforced axles take the extreme bending strain. Thick rubber tires bite the rough asphalt pavement. Independent hydraulic braking systems stand ready. The heavy chassis crawls upward steadily. No slipping, no hesitation, absolute grip. Factories produced only a handful of these machines. Obscure movie cameos faded away quickly. Real heavy logistics work remained. One specific unit found a permanent home in California. It worked there steadily for 15 solid years. Every single week, this experimental tractor navigated public routes, safely transporting industrial loads of 110 tons without ever breaking stride. A deep, low-frequency hum vibrates through the ground long before the machine itself crests the horizon. It sounds less like a conventional truck and more like a heavy industrial generator coming online under extreme load. If American machines of the 70s pulled 150 tons, the French concern raised the bar to 450. This is the Tractomas, built by Nikola Industrie to test the physical limits of wheeled machinery on public roads. The empty tractor alone weighs 40 metric tons, pressing down on the asphalt with the mass of an entire fully loaded commercial rig. The physics of towing such record masses across the open desert require a complete departure from standard automotive engineering. Under the heavily shielded cab lies a monumental industrial power plant. A 27-liter Caterpillar V12 engine generates exactly 1,000 horsepower. The true engineering challenge involves transferring that raw power to the ground without destroying the pavement. A sophisticated 16-speed transmission routes the extreme torque through heavy-duty reducers, carefully distributing the rotational force equally across the chassis. 10 by 10, every single wheel receives power, maximizing traction against harsh desert terrain where shifting sand constantly threatens the mechanical grip. Massive hydraulic brakes and multi-disc systems work together to safely arrest the momentum of 450 metric tons of moving metal. The resulting specifications earned this machine a permanent place in the Guinness Book of Records as the most powerful road-legal truck ever constructed. Instead of using rail systems, engineers deployed this vehicle to haul heavy gas pipelines and offshore drilling modules across desolate highway stretches. One specific unit was delivered to the extreme heat of Algeria, where it transported colossal industrial loads continuously for 2 full decades. The record-breaking 450 tons of the French Tractomas are excessive when the route passes through narrow European city streets. Here, sheer force yields to millimeter precision. The Hayes WHDX Arbogui emerged as a joint solution between Canadian manufacturer Hayes and Spanish logistics firm Arbogui. They built a machine specifically for tight urban geometry. Dimensions are staggering. The truck spans over 36 feet in length. Its super wide tires look like they belong on a military tank rather than a civilian road. Yet this giant threads the needle. The gross operating weight reaches 158 metric tons. Pushing that mass through medieval street layouts demands total control. A specialized 6x6 drive system keeps the chassis stable on uneven cobblestones. Dead stops are frequent. The 18-speed manual transmission engages with mechanical certainty, transferring over 2,000 pound-feet of torque to the axles. This setup allows the crew to crawl forward at a walking pace. Every inch matters. Night falls. Police escorts clear the intersections. The massive truck maneuvers through tight turns, with clearances measured in fractions of an inch. During one standout operation, this specific model hauled a 90-ton electrical transformer across a distance of 500 kilometers. Planners spent months calculating the exact trajectory for every corner. The raw industrial bulk contrasts sharply with the surgical precision of the driving. A single steering error could destroy centuries-old infrastructure. Through constant maintenance and strategic upgrades, one original unit operated under extreme loads for exactly 25 years. 25 years for the Spanish Hayes, 2 decades for the Algerian Tractomas. They prove the reliability of bespoke engineering. Steel fatigues under extreme stress, gears grind, bolts shear, massive loads warp frames, yet they endure. They move critical industrial components, transformers, turbines, heavy generators. They haul weights matching fully loaded commercial airliners. No assembly lines exist here. Each unit is utterly unique. Engineers build them for specific terrain. Designers match them to singular massive tasks. 20 years of constant tension. Microfractures plague the lower chassis. Axles bear thousands of tons daily. Mechanics replace shattered drivetrain parts. Heavy oil coats exposed surfaces. The core steel remains unyielding. Not pristine museum exhibits, daily industrial tools. Railways once held the transportation monopoly. Tracks dictated the inland routes. Now, custom asphalt Leviathans drag whole factories across continents, proving that super heavy logistics have permanently abandoned the iron rails.